A very good afternoon to all of you. So let's discuss the high switching frequency PWM, and I will try to discuss the bipolar and the unipolar both type of schemes in this lecture. First of all, have a look at this. What exactly is happening here? A sine wave is there. A sine wave is there. This is the sine wave, okay? And this sine wave is now being compared with a carrier wave. Clear? I think till this point it is quite clear. Now, what we will do is that we will set. First, have a look at this converter. This is the inverter in which the switching is going to be done. S1, S2, S2, S3, S4. The load will be connected at these two terminals. At these two terminals, A and B, the loads will be connected. Okay. These two, VDC by 2, are the pole voltages. This is are the voltages combined together to form VDC. Okay. Now, what is going to happen next? The things are very simple and easy to understand. This thing is basically your reason when sinusoid is greater than this triangular. Okay, whenever this sinusoid is greater than this triangular wave, then we will get a pulse. Okay, then the second question arises, what will happen then at the next cycle? At the next cycle, when the sinusoid is less than the triangular carrier wave, then at the same time the other two devices, it means S3 and S4, will be fired. Okay, so when the sinusoid is greater than triangular, then S2, S3, it means these two will conduct. Okay, when the sinusoid is less than triangular, then obviously S3, S4 will conduct. So let's have a look at the pole voltages. When this sinusoid is greater than carrier wave, then S1 and S2 are fired. So VA gets directly connected to naught. So the voltage at VA terminal is VDC by 2. Clear? Is it clear or not? Because just by merely switching, by observing the switches, we are going to comment on the output voltage and the what should be its waveform. Okay. Now have a look at this B point. When this B point S2 is conducting, then B point, this is A terminal, this is B terminal. B gets directly connected to O. So VB0 becomes minus VDC by 2. You can say that this point is minus VDC by 2. Is it clear? Now, in the second part, in the next half, or I can say that next part of the duty cycle, when the triangular is greater than the sine wave, then we can easily say that S3 will be fired, S3 will conduct. So the voltage at A, S3, S4, so A is here, gets connected to the negative of VDC by 2 through S4. So VA0 will go to minus VDC by 2. I think this is clear. This is minus VDC by 2 and this is plus VDC by 2, because now this B terminal will get via this S3 get connected to VDC by 2. I think these two parts are very much clear or not? So VAB is nothing but VA0 minus VB0. Clear? Now let's, okay, till this point it is very much clear. Okay, now what will be the voltage? What will be the voltage across VAB? Voltage will be nothing but VA0 minus VB0. Clear? VA0 minus VB0. So VA0 is plus VDC by 2. Have a look at this. It is of the magnitude plus VDC by 2. This is minus VDC by 2. So plus VDC by 2 minus of minus VDC by 2 gives you plus VDC. This is plus VDC. After that, this is minus VDC by 2. This is plus VDC by 2. This gives us a minus VDC. Clear? So this is the output voltage that we will obtain. Clear? Now I would like to show you a very interesting thing. Look at this. in this scheme, this part is positive. Okay, now let's discuss about the reason ahead of pi. Again, in this reason ahead of pi, when this sine wave is greater than this, then you are sure to get the negative pulse. Clear? Sine is greater than this, you are going to get this pulse. Clear? Okay, and but this pulse is corresponding to what? Corresponding to the duration when S1 S2 are not conducting. So obviously now S1 S2 will conduct for this reason, this reason, this reason, this reason. So the operating reason of S1 and S2 is narrow for time period corresponding to theta pi to 2 pi. But in the lower, for the pole voltage VB0, we can clearly say that the operating period is high for S3 S4. Have a look at this. This is operating on time is high. Okay, so one more thing that we can conclude is that this voltage, this and this, both are having a phase gap of pi. Is it clear? Both are having a phase gap of pi. Okay, this thing needs to be understood very carefully. So now we will get the output as plus VDC minus VDC. This is the desired output. Now, how the average pole voltage is calculated? This is again important. Consider a small region. This is a sine wave. I will approximate it to be a straight line. So consider triangle this. That is, first of all, when the sine wave is having magnitude greater than this triangular wave, then we are sure to get plus VDC by 2. Okay, when this sine wave is having magnitude less than that, it is minus VDC by 2. So VA0, when we are sure to get the VN average, is VDC by 2 into T on, the T on time, minus VDC by 2 into T off upon T on plus T off. This is the average voltage. Now VA0 average, the average voltage of what? The average pole voltage corresponding to pole point A. T on can be easily written as DTS, and T off is 1 minus DTS, which gives us this thing, VDC by 2 equal into 2D minus 1. Now have a look at this triangle. This is very important. Just have a look at this triangle. This is triangle. So we will be comparing two triangles. Okay, triangle BDF, that is BDF, this triangle, and triangle DEA, this triangle, and BD, this triangle. Clear? If you compare these triangles, then these are 90 degrees, 90 degrees. Okay, these angles will be equal and these angles are equal. So this is nothing but a similar triangle by AA criteria. Now as these triangles are similar, then BC, we can say BF, that is this upon AE, should be equals to DF upon DE. Clear? Now I will put the values. That is, DF is nothing but T on, DE is TS the entire time, BF is VR minus VC, that is plus VC, and AE is 2VC. Clear? This is what it is written here. So you will get the value of D to be VR plus VC upon 2VC. Obviously this is both the function VR and VC are functions of time. So I have represented them as being function of time. And this VC, be very clear, this VC is a peak value, but this VR is the function of time. So this becomes 2D is VR by T, VC plus 1, that is nothing but, take this 1 aside, 2D minus 1 becomes equals to VRT by VC. Clear? So 2D minus 1 is nothing but VRT by VC. This is very easy. Are you getting it? You have to compare two triangles, that is this triangle and this triangle. Okay. So by triangle comparison, it comes out to be 2D minus 1 is nothing but VR by VC. And now VR by VC and VR is nothing but VM by Okay, now VR is nothing but Vm sine omega t. So 2d minus 1 automatically becomes m sine omega t. Okay, I will continue with this lecture in the next class. Thank you.